What does it really mean for an AI to think? Today, we're diving deep into the question, can Claude replace software engineers? Software engineering remains one of the most expensive and constrained resources in modern organizations. Recent advances in AI coding systems have pushed beyond code completion into planning, implementation, testing, and iterative refinement. The economic gap between human execution and agent assisted execution is becoming increasingly significant. The real question is no longer whether AI can write code, but whether it can participate meaningfully in software creation. But here's where it gets interesting, the real Gatrain, not code, context. Most engineering effort is spent understanding requirements, systems, dependencies, and business constraints. Typing code represents only a small fraction of the software development lifecycle. Existing developer tools primarily optimize syntax generation rather than contextual understanding. As coding becomes cheaper, reasoning about systems becomes the dominant bottleneck. So, what's the real problem? Let's talk about why copilots plateaued. Token level assistance equals architecture level contribution. Early AI coding tools improved productivity by accelerating repetitive implementation work. However, they rarely maintained awareness of larger architectural decisions or long-term design intent. Context windows remained limited, forcing engineers to repeatedly re-explain systems and objectives. As a result, copilots improved coding speed without fundamentally changing software development workflows. This raises a critical question, Cloud Day 2026, the shift. Extended reasoning changes the boundary. New generations of AI systems can sustain reasoning across significantly larger contexts than earlier assistants. Long-running sessions allow design decisions, implementation details, and project constraints to remain connected. Tool usage is increasingly integrated into the reasoning process rather than treated as a separate capability. The transition is subtle but important. AI moves from assistant toward collaborative engineering participant. Now let's zoom in on the system architecture. Not a replacement, a new operating model. Human engineers continue to define goals, requirements, priorities, and business constraints. AI systems increasingly handle implementation, test generation, documentation, and repetitive integration tasks. Responsibility shifts from direct execution towards supervision, validation, and architectural oversight. The relationship becomes a continuous feedback loop rather than a simple delegation model. Here's something most people overlook, core components. 5 capabilities that close the gap. Long horizon planning enables consistency across large code bases and multiple implementation phases. Stateful interactions preserve project context across extended development cycles. Sandboxed execution environments allow safe experimentation and validation before deployment. Tool orchestration connects reasoning directly to APIs, databases, repositories, and infrastructure. Self-verification mechanisms improve output quality through testing, evaluation, and iterative correction. Think about this for a second. The workflow. Human defines intent. Claude maintains integrity. Development increasingly begins with specifications rather than direct implementation. AI systems transform requirements into plans, plans into code, and code into validated outputs. Human review remains critical at strategic checkpoints where trade-offs and priorities are evaluated. The workflow becomes cyclical, combining machine execution with human judgment. And this is where things get complex. Measured impact. What changes in practice? Teams report substantial reductions in repetitive implementation work and boilerplate development. Senior engineers often spend less time producing code and more time reviewing system-level outcomes. Verification, testing, and quality assurance become increasingly important rather than less important. Productivity gains do not eliminate engineering roles. They redefine how engineering time is allocated. But here's where it gets interesting. What Claude cannot do: the persistent gap. Many high value engineering decisions involve organizational context that exists outside technical systems. Stakeholder alignment, prioritization, and negotiation remain deeply human responsibilities. Incident leadership during outages requires coordination, accountability, and rapid judgment under uncertainty. Regulatory interpretation, risk acceptance, and strategic trade offs continue to require human ownership. Capability is not the same as accountability. So, what's the real problem? Let's talk about the 2026 reality. Replacement is the wrong frame. The most successful organizations treat AI as a force multiplier rather than a workforce substitute. Engineering work increasingly shifts from implementation toward verification and orchestration. Junior engineers focus more on testing, evaluation, and workflow management than manual coding. Senior engineers become responsible for governance, architecture, and system level decision making. This raises a critical question: the horizon. From implementation to specification, software development is gradually moving toward intent driven workflows. Natural language specifications become increasingly important as interfaces for software creation. AI systems generate larger portions of production ready systems, while humans define objectives and constraints. The competitive advantage shifts from coding speed toward clarity of thinking and quality of specifications. Now, let's zoom in on closing. Claude does not replace engineers. The act of manually producing code becomes less central to software development. Architecture, governance, validation, and strategic decision making become more valuable. The engineer's role evolves upward rather than disappearing. The future of engineering is not human versus AI. It is human judgment amplified by AI execution. So Claude does not replace engineers. Claude replaces much of the typing. Engineering becomes architecture.